Hello everyone, I hope all of you are fine. So today we are going to start with exercise 5.1. So already we have studied or read the all axioms and postulates. So according to the knowledge that we have uh, acquired in the previous lecture, accordingly we will start with this exercise, and all axioms and postulates we can use if it is required in the questions. Okay, so let us start with the questions then. Which of the following statements are true and which are false? Give reason for your answer. Okay, you will give. Then only one line can pass through a single point. Is it? First, no. From a single point, you can say infinite number of lines can be passed, or simply write can pass. So write no. Infinite number of lines can pass through a single point. Single point. And example you can give to justify this, because they're asking for a reason. No, so just mark one point and just draw lines passing through this point. Oh, it should be like, okay, so many lines we can draw passing from this point. So this is the only reason. Next, so this is proved. No, now second, there are an infinite number of lines which can pass through two distinct points. See, we have 2 points. Let us write the answer first of all. No. Why no? Because only one line we can pass from two distinct points. No, only one line can pass through two distinct points. If we have two different points, then how many lines you can pass from them? Only one line. For example, there are 2 points A and B. There are 2 points A and B, A and B. So let us pass a line passing. Let us draw a line passing through this point. Uh, I have tried to pass from here. Okay, so it's like this. So how many lines we can pass? Only one line we can pass from two distinct points. See, if you want to draw one more line which should touch these 2 points, then it is only possible if you are making the another line on this line. For example, see here, this line is not passing from these 2 points because this line is not lying on that line. If I'll see this, let us drag the line over this line. See, the another line which is able to pass from these 2 points is lying on the previous line. Yes, no, the previous blue line that I have made and this black line that I have made, both are lying on the same plane, means they are coinciding each other. They coincides with one another. I know. That's why we can say that only one line can pass through 2 points. If you want to make another line, then that line will also lie on that line. So it means only one line is possible. Okay. So no two or three lines. So this is the only answer. So you can draw 2 points and one line you can pass. Simple. There is no need to make two lines. Okay. So let me drop this part. So like this you can draw. And either you can make the arrows. Okay, next, third part. A terminated line can be produced indefinitely on both the sides. Yes, it is true. Yes, terminated line, terminated line can be produced indefinitely, indefinitely on both the sides. And if you remember, this is one of the postulate on both the sides. You can write here directly according to postulate 2, according to postulate 2, which is a terminated line, but we need to write it again and again. So it is better to draw a figure. Okay, that will be better for you. Just leave this. Do not write according to postulate 2 because this is only postulate 2. Okay, if you remember postulate 2, just see this. In our previous videos, we have written this is postulate 2. A terminated line can be produced indefinitely, and this only they are asking. So why to write again this line as the reason? So that will not justify it. So let us write that yes, terminated line can be produced indefinitely, and the reason for that is our example. Let us make a terminated line. So this is our terminated line AB. Let us produce this indefinitely, making again the terminated line. Okay, let it be uh, AB. Can't we produce this? Let us show the endpoints. Okay, I have redrawn this line. Okay, I have drawn this line again with the same length and all everything. Okay, now I have to show that this I can produce. We can produce this. See this? Just wait. Oh, so like this, we can produce this side and this side even. Okay, or I know, or wait. Okay, from this side also we can produce, and after that, no, make an arrow like this, because this is a terminated line and this is known as line segment. Okay, and to make it a line, we have to make the arrows, and you can extend them both the sides to show this is proved. Okay, yes, this is a terminated line, a line segment. I have told you that terminated line is also known as line segment, and we have produced it from both the sides. And in the same way the arrow are made, it means we can produce them indefinitely from both the sides. So this is done. Or you can write here AB lines segment is produced from both sides. Okay, after this, the fourth part, see this, if two circles are equal, then their radii are equal. Okay, yes, if two circles are equal, then their radii It is double I. Okay, radii will be equal, or then the radii are equal. What reason we can give for this? Right after this, because because their centers centers of the two circles I'm talking about, because their centers and circumference means perimeter of the circle will coincide. If two circles are equal, no, then their centers and circumference, everything will coincide. If everything is if everything coincides, it means so radii will also be equal. Okay, if two circles are equal, then their radii are equal because their centers and circumference will coincide. So there is no need to write again this. Okay, so here only you can end this. I hope this is clear. See, let me give you an example. Let us make a circle here. Okay, and if I want to make one more circle with the same radius, that also I can make. Okay, this is a big one, is big, one is small. Here no, I am making a rough circle, that's why it is becoming. Suppose these two circles are equal, then they will both coincide each other. So let us move this circle this side. See this, both the circles are equal, that's why they coincide each other. Okay, if they coincide each other, then their center will come at the same point. If the center will come at the same point, then the distance between the center and the circle is radius. The distance between the center and the circle is what we call radius. Okay, so radius of both the circle will be equal to each other because both the circles lies here only and their centers are same, their circumference are same, then the distance between the center and the circle will also be same in both the cases. That's why coincides mean this, that both the circles will cover each other. Okay, so it's done. Moving on to, there is no need to make this figure. Okay, this is just for your understanding I have made, or this reason is just see, it is justifying this. Okay, after this, moving on to the fifth part, AB is equal to PQ. Very easy. See this, AB and PQ are equal. They are saying AB line and PQ line are equal to each other. Let it be 3 centimeter and 3 centimeter. Fine. PQ is equal to XY. Okay, PQ is equal to XY. PQ is 3, then XY will also be 3. Now they are saying AB and XY are equal. Yes, AB and XY are equal. See this, 3 and 3. I have given you this example of 3 and 3. It doesn't mean that the measurement of this line is 3 centimeter. This is just an example to explain you. If AB and PQ are equal, I have supposed here 3 3. Okay, because both are equal, I have given same value. Then PQ and XY are equal. If PQ and XY are equal, if PQ is 3, then XY will also be 3. Then AB and XY, will they be equal? Yes, they will be equal. But we have not to give examples. We have to use here axiom. So let us see which axiom we can use. Solution of fifth. Write AB is equal to PQ. Then PQ is equal to XY. This is given. If these two things are given, therefore we can write that AB is equal to XY. So we can write that AB and XY are equal to each other. Why we can write that this? Because AB equals to PQ and PQ is equal to XY. This is common in them. That's why they will be equal. And axiom we have to write that things which are equal to the same thing are equal to each other. So let me explain you this. This we have written in axioms. See in our axioms. things which are equal to the same thing, the very first axiom. Things which are equal to the same thing are equal to one another. Same I have written. Things which are equal to the same thing are equal to one another, or each other are equal to one another. Okay, we can write the same wordings are equal to one another. So what are the things here? Things which are equal. Okay, these two things are equal to the same thing. See this PQ. This is also equal to PQ, and this is also equal to PQ. If things are equal to the same thing, then they will be equal to one another. Then these two things, AB and XY, will be equal to one another. So I hope this is clear. So fifth part is clear, and first time we have used the axiom. Now in question number 2, you have to write all the definition of this. Give a definition for each of the following terms. Then we have to write the definition of all this much only. We are going to just define these terms. So I am writing, you also have to write in your notebook the definition of this. Why I am saying that we have to write only the definitions? So you should know the definition of each and every this word which is written here, the terminology. Okay, but they are asking, are there any other terms that need to be defined first? What are they and how might you define them? See, this whatever is written after that, no, that will discuss, means that I'll tell you verbally, but I'm not going to write that. Okay, there's no need to write that, just you should know, that's it. Okay, and we are going to write the definitions only. Okay, question number 2, right? First definition, and we'll show that figure also something. Okay, so write first parallel lines. So what are parallel lines? If between two lines, if between two lines perpendicular distance is constant, then lines are called parallel, or you can say parallel lines. Just note it down. If between two lines perpendicular distance is constant, then the lines are called parallel lines. Okay, let us draw these parallel lines. A line, then one more line, so let it be line L and let it be line M. So I have given this line a name L and I have given this line a name M. If these two lines have equal perpendicular distance, so what are perpendicular distance? So from here to here, a straight line means a perpendicular line. See this, it should make 90 with this, and it should, or this line should also make 90 with this. So this is a perpendicular distance. Okay, so let us talk about here again the perpendicular distance. If this distance between these two lines, the distance here and the distance here, if these distances are same, then obviously the distance between these two lines will be same everywhere. We have to just check 1 2 3 times. If the distance is same, I have not measured it, this way we can check with the help of scale. Okay, that you can keep your scale from here to here and you can measure how much is the distance. You can measure again how much you can measure here again, here how much is the distance. If the distance is same everywhere, it means the lines are parallel to each other. Okay, and before defining parallel lines, we should know the definition of perpendicular lines. Okay, that the distance between these lines. Okay, so this only they were asking. Is there any other term which need to be defined first? Yes, we can say that perpendicular lines should be defined first to explain parallel lines. That's it. I told you no that we are going to discuss that. There is no need to write that. Okay. Then perpendicular lines. Eh, okay. So actually no, why we are writing definition? Because definition you sometimes comes in exams. So you should be prepared for the definition. Okay. In this chapter we have theory part also, no, axioms, postulates we have to learn. Then some definitions also are required to learn. Perpendicular lines. Now what are perpendicular lines? If two lines intersect each other at 90, if two lines intersect each other at 90 degree, then lines are called perpendicular. Sign is this, no, so I am making this sign perpendicular lines. Okay. So let us make these perpendicular lines. Okay, one more. If they are making like this 90 degree, they are making 90-degree angle everywhere. Okay, it means they are perpendicular lines. If one will be 90 this way, then others will also be 90 degree automatically. So let this line be L and let this line be M. Both are intersecting at point, suppose this point be O, and they are making 90 here. So it means these two lines are perpendicular. So what should be defined before defining perpendicular lines? We should know what are lines and what are angles. If we know the definition of lines and angles, then we'll be able to understand what are perpendicular lines. Simple. Okay, as in the question it is written that are there any other terms that need to be defined first? Yes, you can say that here the definition of angles and lines a student should know, then he'll be able to understand perpendicular lines. Okay, then third part. After perpendicular, it is line segment. Very simple. Line segment, we can say a terminated line, that I have told you while explaining postulate number 2. Postulate number 2, no, a terminated line. So what is line segment? You have usually heard that a line segment has two endpoints. So we can write a straight line drawn from one point to another point. A line which you are starting from one point, it ends at another point, is called line segment. So these all definitions are very easy that you have done in 6th, 7th, 8th grade. So now it's just a repetition. You can make again a line segment where we can highlight the endpoints. Let it be A and B. So AB is a line segment which ends from one, which starts from one point and ends at another point. So for the definition of line segment, you should know the meaning of a line. Means you should know the meaning of uh, points, and nothing else. Okay. Rest we have, I have told you regarding the line segment. To define line segment, you should know regarding the points. If 2 points you know how to draw, then you can join them to make a line segment. That's it. Okay. Then fourth is radius of a circle. Radius. A very easy definition: distance between the center to the to any point on the circle. So distance between the center of a circle to any point on the circle. From center to any point on the circle, if you will measure the distance, that all distances will be radius only. So distance between the center of a circle to any point on the circle is called radius. Okay. After this, the fifth point, or here no, you can make a circle this way. Okay, and we can mention here a point at the center, and from the center we can draw a line to represent a circle. Oh, sorry, to represent a radius. So this is a radius. Starting from the center to any point on the circle, radius. Okay, now fifth point. Fifth is square. So how you can define square? So a quadrilateral, first of all, our square is a quadrilateral. Quadrilateral having all sides equal and all angles 90 degree. So any quadrilateral which have all the sides equal and all angles 90 degree, okay, is a square. You call it a square? No, a quadrilateral with all sides equal and all angles 90 degrees, a square. And if you want to define a square, then before this you should know what is a quadrilateral first of all, and you should know what are the sides and what are the angles. See, three terms we have written here: sides, angle, and quadrilateral. You should know the meaning of this first, then you will be able to know the meaning of square. So let us draw a square here. Suppose this is a square with all sides equal, where we can mark them. We can name them. It is name it, that is ABCD. So here ABCD is a square with all the sides equal and all angles 90 degree. So we are done with the definitions. Okay. So in today's video we are doing till here only, and rest of the exercise will complete in the next lecture. Okay. So it's done for today. Okay, bye. Take care. Write all these definitions and try to learn all the things which we have written till now. So, homework, write all what all definitions. Just I can write here. Do question number 1, 2. 1 and 2 question only we have done, no? So, only 1 and 2 you have to do. Fine. Of exercise 5.1. Okay, bye.